resistors in series. Let's say we have a circuit where we have a battery, positive side, negative side, and it's connected to 3 resistors that are connected in series, which is to say that there's only one line that connects all 3 resistors. And there's only one path for the current to go through in order to go through the resistors. So we have some I. And each of the resistors has a different resistance, R1, R2, and R3. Now we want to find an equivalent circuit with the same battery, plus minus, but this time there is only one resistor, and this resistor has a resistance of R. Now in order for these to be equivalent, we want to find the relationship between R and R1, R2, and R3. First off, we can start by noting that the current that goes through all of the resistors is going to be the same, since current must be conserved, and since there is only one path for the current to go through, each resistor receives the same amount of current. Another thing to note is that the total V, namely the V from perhaps point A to point B, point A to point B, we'll call this large V. And we can see that it's going to equal to the voltage drop from each of the individual resistors. Now for our equivalent circuit, we have the same A to B, but in this case the voltage drop is only going to be from one resistor, namely large R. For our circuit on the left, we have V is equal to V1 plus V2 plus V3, the sum of all the voltage drops. Now, based on this equation and the equation which is called Ohm's law, we find that Ohm's law states that V is equal to IR, or namely voltage is equal to the current times the resistance. So V1 is going to equal to I1, R1, and since we know the current is all the same, it's just IR1, and similarly for V2 we have IR2, and V3 we have IR3. Now if we plug all these 3 in, and we know that for this circuit, V is just going to equal IR, we know that V is equal to IR, which is equal to V1 plus V2 plus V3, the sum of all the voltages from each of the resistors, and which is each of them is equal to, as we have figured out, the I times their respective resistances. And since there is an I common on all sides, if we can sort of ignore these two in the middle, we would divide it by I if we were still using them. But what we get is that R is equal to R1 plus R2 plus R3. So we find that our effective resistance is just going to equal to the sum of the resistances of all of the individual resistors. And if we have more than 3 resistors or less than 3 resistors, we simply just keep adding their resistances until we have added all of the resistors that are in series with one another. And thus we have found an expression for the effective resistance.